Hey everybody, it's Mr. N here, and in this video, I'm going to go over some proof strategies for you guys. So we often get the question as teachers, how do I do a proof? Where do I start? So these are some strategies to help you out, to give you that initial push to see what to start and what you do. First of all, as with anything you do, any problem, make sure you read the problem completely and form your action plan. Try to ask yourself, what am I trying to do with this? What am I trying to prove? What do I ultimately want to do? What is my ultimate goal? So take a look at everything, all your givens, and just mark your congruence. Just look at the whole picture and try to start from there so you kind of understand what the problem is asking you. Next, you look at the given. If you're told something is a midpoint, so if I'm given that, suppose I have this, and I have segment AB, and I'm told that this is a midpoint, well, right away I can say from that given that AM will be congruent to BM. So those two segments would be congruent. So take a look at what the given says, and then decide what you can say right after that. If you're given that something is supplementary, well, what do you do with supplementary? You add them up and set them equal to 180. But often we get this given that really we can't say anything from. So at this point, when you're given, you can't really say a next step. Look at that diagram. So sometimes you'll be given a diagram that, say, looks like this. And you have angle 1 and angle 2. And they'll just tell you angle 1 and angle 2, and you have like something like line L right here and line M right there. Well, there's not going to be much given, but when you look at this, you could say, oh, take a look at this. These are a linear pair. So angle 1 plus angle 2, those are supplementary. They're going to be 180. So that's something you can conclude by looking at a diagram. So look at the diagram. If you see something that looks like this in a diagram, such as that, two lines intersecting. Again, we'll say line L and M. Here's angles 1, 2, 3, 4. Well, what can you say from that? You can say that 1 and 3 are vertical angles. So those will be congruent. So those measures will be equal. 2 and 4 are vertical angles. So use the diagram, look at the diagram, and state the things you can make from the diagram. So we all have in proofs, we'll typically start off doing T-charts with our statements and reasons over here. And we're always going to do the given as our first step. So you should always get the given correct. And then from that first step, like I said, you think of the given. If you can say something, say it. If not, look at the diagram, say something based off the diagram. It's okay to start off and write things and then erase and do it all over again. And then sometimes you might have to, you get stuck. Well, what are you ultimately trying to prove? Look at the conclusion. Maybe you can work backwards from the conclusion. So if we see that we have to prove two segments congruent, so maybe I can look at something that makes up those two segments. So such as segment addition. AB plus BC equals AC. Perhaps I'm trying to throw in an AC in there. So look at the conclusion, what you're trying to do, and work backwards. Some words and phrases to look for. Now, it depends on what section and what types of proofs you're doing at that moment in geometry, but let's look at some of the key things. The first is segment addition. If you come across a problem where you see something you got to prove about segments, typically the one we see the most is you'll often see this one where I have like A, B, C, D, and I got to prove something, and I know something about AB congruent to CD, and I got to prove something that A plus AC is congruent to BD. Well, this is a pure segment addition one because right away when you look at this diagram, you can tell me that AC is made up of AB plus BC. And then you could say BD is made up of BC plus CD. So right away I said something, and then you should notice that both of them have something in common. And you can kind of put that together and piece it from there. Angle addition would be the same way. If you're going to add up angle 1 and angle 2, well, you can add these up. We can set up another angle here and call this 3. So you could say 1 plus 2 is 2 plus 3 if they give you the proper information to do that. So try to add up the angles. If you see a line, such as we did above, and you have something like this, well, you know that this is a linear pair, so you know the measure of angle 1 plus the measure of angle 2 will be 180, because a linear pair is supplementary. So always look for this word supplementary, just like you're going to look for this word complementary. If you somewhere in the given that you're told something is complementary, well, you automatically know it's going to add up to be 90 degrees. So if you're given complementary, try to add up the angles to make them 90. If you're given the word midpoint, well, we did it above, but again, if you have A, B, and C right here, and you're told that B is the midpoint right away, you could tell me that AB is congruent to BC. If they use a bisector, so if I say that this line L bisects segment AB, right away, since it's a bisector, I'll know that that's the midpoint. I'll know that AM equals 1/2 of, or I'm sorry, AM right here. Let's redo that. AM will be 1/2 of AB. That's what the bisector will tell me. So M will be my midpoint. AM will be congruent to BM. If I see something such as vertical angles, right away with vertical angles, we know there's a congruence in there. So we could say 1 and 2, those are vertical angles. Angle 1 will be congruent to angle 2. Reflexive. Reflexive you'll often see in triangles. So if you're trying to prove triangles congruent, and this is AB, well, part of it, you know AB will be congruent to itself, AB, by reflexive property. So try to introduce something like this if you see reflexive, because maybe you might be substituting that in, or maybe that's part of one of the sides you need to show congruence to. Other keywords that you might see here. So other keywords you might see here, maybe if we're talking about parallel lines. We know that a lot of theorems involve parallel lines. So suppose I had 2 lines here, and these were parallel. L is parallel to M. I know my drawing doesn't look so great, but if I tell you that these are parallel and put my parallel symbols, if I have a transversal, right away you'll know things, and I'm just going to label this. Alright, so if I have a transversal, right away you know that angle 1 will be congruent to angle 5, because those are corresponding. Angle 3 will be congruent to angle 6, because those are alternate interior. So those are things you can say in your proof right away. If you're given parallel lines, you can say, oh, angle 1 is congruent to angle 5 by corresponding. So look for parallel lines. If you're trying to show lines are parallel, look for the congruent angles, what makes something congruent, and then you can show the lines are parallel. For triangles, we kind of talked a little bit above 4 triangles. This is a biggie, CPCTC, so you're trying to prove the triangle's congruent, and then all their corresponding parts will be congruent. Later in the course, we're going to learn side angle side, side side side, etc. And those are things that we will look for to try to prove triangles congruent. Look for the word isosceles. If you have a triangle that's isosceles, then you know that, well, let's say A, B, C, you know if it's isosceles, it'll have 2 sides that are congruent. So you could right away in your proof say AB is congruent to BC because of an isosceles triangle. And again, often you'll see like triangles sketched kind of like this, and you'll have vertical angles here. So maybe you could say something about the vertical angles that make up those triangles. And then you'll come across problems that involve circles. For circles, draw all the radii. So suppose you had a circle. Well, you don't always have to have this as the radius. you can draw it this way. You can draw one over here. Draw multiple radii because it might help you. And then always remember, one of the biggest theorems we have is if you have a radius and you have a tangent, you'll end up with something perpendicular there. That's one of our biggest theorems, and look for those perpendiculars because there's a lot of things we can conclude from that. And then finally, just know your theorems. It's helpful to keep them all together, so that way you can kind of look through them back and forth and try to use the ones you need. There's some that'll come out sometimes that you are not expecting, like the supplements theorem, the complements theorem. And many books will also put these in the back in some sort of appendix, so maybe you can refer to that and have that handy and just be looking through those theorems to see which one will help explain. But again, remember, always remember, for proofs, for everything you say, for every statement, you need that reason. Whether it's a T-chart, whether it's a flowchart proof, where you have your statements here and your reasons underneath, or whether you do it as a paragraph proof and write it all out. For everything you say, you better have a reason. Now, hopefully this has helped. At least this will get you thinking as to the steps you do next when to start a proof. So make sure to check out all my other videos that I have posted and I'll be posting on proofs with specific examples of ones that are common and ones that you may see. So thanks for watching again. Hopefully this helped, and good luck with all your proofs.